right, hi everyone. This is lesson 2 in our linear relations unit for Math 9. We're looking at some real life scenarios here today with linear patterns and interpreting some graphs and also drawing a graph as well to represent those scenarios. Okay, so let's look at the first example and let's look at the graph here and see what's going on. So on the x-axis we have distance, and that's measured in kilometers. And then on the y-axis, we've got volume, and that's measured in liters. And we can see from the title of the graph that we're looking at the volume of gas in the scooter. So it looks like the volume of gas is decreasing over time. That makes sense because as you drive, you use up your gas, right? Okay, so let's answer the questions. Is the relationship continuous or discrete? So this relationship is continuous. We talked about these two terms last time. One way we can tell it's continuous is by thinking about whether or not we can split up these distances into smaller and smaller increments, and if it still makes sense to ask the question like, how much volume is there if we travel 20.5 kilometers? And it does make sense to ask that question. Like, we would have points along this graph in between the points that are already drawn. Also, on the graph, we see that the points that are there are connected with a line, and that's another indication that you have a continuous relationship. So I'm going to put here, the points are connected with a line. So when you're drawing your own graph, if the relationship is discrete, don't connect the points with a line, but if it is continuous, you should connect the points with a line. Points are connected with a line. Okay, on to part B. Describe the relationship in words. So if you're asked to describe a graph in words, what they're asking for is to describe like the pattern, like how is the volume over time changing with the distance, and be specific as well. So let's pick 2 points on this graph. Let's pick this point here and this point here. So at this point here, I've traveled 0 kilometers and I've got 8 liters of gas in my scooter tank. And then at the next point, I'm halfway between 50 and 100, so that'd be 75 kilometers. So I've traveled 75 kilometers and now I only have 6 liters of gas in my tank. So let's write that in a sentence. The scooter uses 2 liters of gas for every 75 kilometers traveled. Okay. Part C, what is the vertical intercept? So the vertical line is this line here. It's the y-axis. I'm going to label it vertical axis, also known as the y-axis. The horizontal axis is this one, and that would be the x-axis. Okay, so what they are asking for intercept is where does the graph intercept that vertical axis? And we've actually already labeled this. It's right here at 0 kilometers and 8 liters. So the vertical intercept would be at 8 liters of gas, and it asks what's the significance here. So that would be how much gas was in the tank to start with. Maybe it's the size of the gas tank, if the gas tank was full at the beginning. Interpolate to estimate the volume of gas left in the tank after driving 100 kilometers. So what it means by interpolate is to look, estimate a value that's within the points that are already on the graph. So let's go ahead and do that. So we're going to look at 100 kilometers, which is right here. And I'm going to look at the graph and estimate the volume of gas there. So it looks like it's just above 5. So 5 would be right here. So it's just above 5, maybe 5.3 or 5.2 would be a good estimation here. We don't need to actually calculate because the question just says estimate. So we're going to estimate a little more than 5 liters. Maybe 5.3. Okay. And last question, extrapolate to estimate how long the scooter can go before it runs out of gas. So what it means by extrapolate is go outside of the region that's already shown on the graph to us. So we're going to extend our graph. So if you have a ruler, use it. I can't use one on my screen here, so I'm just going to extend this down. And it looks like we're going to intersect the x-axis at about 300, kilometers. So 300 kilometers. This would also be the horizontal intercept here. Okay, so again, the difference between interpolate and extrapolate. Interpolate is going within the graph that is already shown. And extrapolate is to like extend the graph outside of what is already shown. What is shown. When we're extrapolating, we are making an assumption that the graph continues at the same rate, so the scooter is using the gas at the same rate, because we don't know that for sure, but we're just assuming that to answer the question. Okay, let's go to the next example. Drawing a graph to analyze data. So we're going to be drawing a graph here. I chose numbers that would work out fairly well so that we can choose our intervals pretty easily for the graph. We're looking at the cost of a subscription to a fitness app. So I'm going to go ahead and just start with the title of my graph. We're looking at the cost of an app over time. And we're given a table of values here. So it looks like the cost of this app, it starts off as $25 and then it's going up by $10 every month. So this relationship is linear, it's increasing at a linear rate. If I was going to make an equation, which we practiced last day for this app, it would be starting at $25 and then we're going up by $10 every month. So if N was my number of months, it would look something like this. C is the cost. Okay. Part A, plot the points on the graph for an entire year. So obviously in the table here, it only goes up to 4 months. So to figure out what my scale should be, I need to figure out what my cost is gonna be for a whole year, and then I can figure out what I should increase by on the X and Y axis. So if I plug in 12 into my little equation there, that means I'll have 12 increases of 10, and then I started at $25. So that would be 145. If I count the number of lines here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 15 lines. If I go up by 10, that's going to be a nice, I'm going to use up the whole space, and 10 is kind of a nice number to go up by. So always start your graphs at 0. That's very important. I'm going to have cost here on the y-axis. We always put whatever is in the second column on the y-axis, and then we always put whatever's in the first column. That's going to be our independent variable, and that always goes on the x-axis, always. That way we'll all have the same graph. So we're going to have time in months here and cost here. So I'm going to go up by tens for cost, but I'm not going to label every single one just because I feel like that looks really cluttered and it takes a long time. So I always label every second point, especially when the lines are close together. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 120, 140. Perfect. And for time, I'm going to go up by ones because it asks us to do a whole year, and there's about, I think there's 14 there, so that makes sense. So I'm going to label every second one again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. That would be a full year. And let's plot our points. So we're starting at 25, which is halfway between 20 and 30. So right here. And then we're going to 35, which is halfway between 30 and 40. And you can see as you plot more and more points, they're going to be in a straight line. So it's actually kind of straightforward to plot them because there's a nice pattern to it. And we should not connect our points here. And finally at 12 months, we're at $145. We should not connect these points because this is a discrete relationship, because you only get charged once a month for this app. Probably that's kind of how subscriptions usually work. So it wouldn't really make sense to split up the time into smaller and smaller increments, like days or minutes or seconds, because you're just charged once a month. Okay. Is this a linear relationship? I've already mentioned that. Yes, there's two ways you can tell. One way is that the cost is increasing by a constant amount. The second way you can tell is by looking at the graph, because see how all the points are in a nice straight line? That means the relationship is linear because it's increasing by a consistent amount. The points on the graph are in a line. The word, I sometimes tell students, the word linear has the word line in it, and that's how you can remember that your points will line up in a straight line. Okay. Interpolate to determine when the total cost will reach $100. So I'm going to use my same highlighter here. Here's $100. And so it looks like it's going to be after you hit 7 months, between 7 and 8 months. So I'm going to put after 7 months. That's when your cost will be over $100. So a couple of points I wanted to reiterate here about the graphing. Make sure you're going up by consistent amounts. So I didn't change how much I was going up by. So for my cost, I went up by 10 every single time. And I start at 0. That's very important as well. Also important to label your axes and give your graph a title, and also put any units that are being used as well. All right, so that's the end of the lesson.